Welcome, everyone, and thank you for joining us today. My name is Kara, and I'm with the LTAP Center here at ODOT, and I'll be your host for this webinar. Today's webinar is part 4 of Work Zone Traffic Control and Safety, and we are thrilled to have our own Ray Brushart as the presenter. Before we begin, I'd like to cover a few housekeeping items to ensure a smooth webinar experience for everyone. If you have any questions during the presentation, please use the questions panel on your screen. You can type your questions there, and we'll address them when the opportunity is given or during a Q&A session at the end. If you're experiencing any technical difficulties or have any other issues, feel free to use the chat panel to communicate with our team, and we'll do our best to assist you. Also, please note that this webinar is being recorded, and the recording will be made available to all registered attendees within 24 to 48 hours after the session. Lastly, we encourage you to participate and engage during the webinar. We may have some interactive polls and/or discussions, so be ready to share your thoughts and opinions. All right, with that out of the way, let's get started. It's my pleasure to hand it over to Ray. Ray, the virtual floor is yours.
Oh, thank you, Kara. Very nice.
You're very welcome.
All right. Well, welcome back, everybody. It's time for part 4. And so glad you guys made it through 3 parts so far. So just one more hurdle to go, and it'll all be over. Okay, so as we get started today, I discovered some more slides on flagging and mobile operations, and also had a question from one of our City of Columbus attendees about flagging, about when can you use just one flagger out there. So I want to go over some of those stuff. So back when we were talking about flagging, when we were talking about the flaggers need to have 3 basic flagging skills, which are stopping traffic, releasing traffic, and slowing traffic. And I know you have in our guidelines for traffic control in work zones booklet, sometimes called the ODOT flip book. I think that's one of the handouts. There's pictures in there at the beginning of that of how to properly stand and hold the stop slow paddles, and to stop traffic and to release and slow traffic. And then I went over the slides showing an actual flagger standing properly, of stopping traffic, looking at the traffic, making eye contact with the motorist, having your right arm stretched straight out, holding the stop sign facing the motorist, and your left hand, the palm facing the motorist. And then how to release traffic, and you do not wave the sign, you point to the open lane like you see in the picture there. And then slowing traffic, using your free arm to motion traffic, you move it up and down like you're pushing down to get people to slow down. And here's an example of where not to stand if you're a flagger. And then we want to talk about flagger operations and how they talk to each other. The most common way is by radio, 2-way radios. And so communication and teamwork is essential, and one flagger is usually in charge. And then, here's the picture shows typical application number 10, which is what your flagging operation is based on, which shows all the signs and the cone placement for the taper and throughout the buffer and workspace, and the flagger standing at the beginning of a taper that's 50 to 100 feet long. That's the 2-way taper. And then here's another example of typical application number 10, drawn as a standard construction drawing. So communication between flaggers. A lot of times you can see each other and you can communicate by sight and have some signals for each other. Or if you can't see each other, you got your two-way radios, and then it says flag carrying method. Uh, that's a method that's rarely used, but it could be used. Like, a lot of county engineers and townships in Ohio, they like to, uh, when they have their chip and sealing operations, sometimes they pave for like a mile at a time, and that would be a good situation to use the flag carrying method, where you give the flagger hands a flag to the last person in the group of vehicles going through the work zone, and then that vehicle hands the flag to the other uh, flagger at the other end of the job and lets them know they're the last vehicle. Um, all right, so this is where I wanted to talk about this single flagger. I had a question on that. So when can you use a single flagger? And a few conditions have to be met for this operation. And usually, you want to do this only on low volume, low speed roadways, and where you have good visibility. I mean, it's good sight distance in both directions, and the workspace is short, and it's a short duration task, like an hour or less. And then, so here's an illustration of a single flagger operation, showing that the flagger is standing directly across from the workspace, controlling both directions of traffic. And then here's some pictures of a single flagging operations. You see them over on the shoulder, never in the lane of traffic. And he's got some cones there at his feet to draw attention to himself. He's also wearing a class 2, minimum class 2, or even a class 3 vest. And so you want to make sure you're visible to traffic from both directions. And you still have all your signs in place. So, um, so that's the single flagger operation. And then, of course, if you have a really long flagging operation, like on those long paving operations, and sometimes you have public street intersections where you would have to place flaggers at each intersection. Of course, they'd be in direct contact with each other. And then here's a situation of flagging near a railroad crossing. And so the objective here is for the flaggers to make sure that they never allow traffic to stop on the crossing. You got to keep them moving when they're on the tracks. And then nighttime flagging. Sometimes we've got to flag at night. And when you read the notes page on typical application number 10, there is one standard, and it's all about illuminating the flagger. And that's not with headlights. You'd have a special light shining on the flagger like you see in this picture. And you'd have other special equipment for nighttime, like a flashlight with a glow cone, and class 3 garments. Class 3, that's an upgraded vest, plus there's actually trousers that go with that, and everything is retro reflectorized. And your stop slow paddle must be retro reflectorized, and I've even seen some that have LED lighting, like I think this one here has LED lighting. Okay, and it talks about having a plan in place for if an emergency squad needs to get through. You want to make sure that it actually is safe for that emergency squad to get through, even if you have to stop it to clear the way to make it safe. And then if a crash does happen, you want to be prepared for that, prepare to respond. Emergencies like a crash might occur, or you might have a driver disobeying your command. And so, we need to make sure that you alert your workers. A couple ways to do that is with an air horn or a referee's whistle. But then you also want to notify your supervisor if there's a crash, and then if you can get the license plate of the car that disobeys you and goes through, they can be cited for that. Okay, so those are just some extra slides on flagging that I wanted to share with you. And then I also had more slides on mobile operations. Plus, I never got around to showing you the that there actually is a typical application that other states use for combining flagging with mobile, which works quite well on local streets. Our ODOT crews don't do that, but sometimes it makes sense to do that on local streets. Okay, so mobile operations, we talked about typical application number 17, mobile operations on a 2-lane road, but there's also a typical application number 35, which is mobile operations on a multi-lane road. Moving and mobile operations, we're talking about work that moves intermittently or continuously. The work area and the workers are in motion. And so, there actually is a difference between moving and mobile. There's a distinction between them. Moving operations are a special case of mobile operations. So let's look at some examples of a mobile operation. That's where you're staying in one location fewer than 15 minutes, usually during the day. So some examples of that might be manhole inspections, aerial cable replacement, or even overhead light repair, or maybe even changing the bulb in a traffic signal. Then we have moving operations. So an obvious example of that would be if you're painting pavement marking striping, like the white edge lines or yellow center lines. Or other examples of moving operations are street sweeping, mowing, surveying, or litter and trash pickup. So in other words, if you're doing any of those operations, then you must abide by one of the typical applications, whether you're on a 2-lane road or a multi-lane road. So you're either using TA 17 or TA 35. So making sure you have the proper traffic control procedures, and you don't want to surprise the motorist with your presence in their lane. And we talked about the importance of advanced warning and guidance around the workspace, how important that is to reduce the chances of crashes happening. And even though you're a moving or a mobile operation, you're still moving much slower than the regular traffic, so that makes you a target for trouble.
Hey, Ray, we have a question.
Okay.
The question is, so all moving operations are mobile, but not all mobile operations are moving, or is it the other way around?
I think you got it right. Moving means you're constantly moving. Mobile is moving is where you're doing the work as you're moving, and then mobile is you stop and do the work and then move on, but you're not stopped for very long, maybe up to 15 minutes and moving on. That's why I listed those tasks that take 15 minutes or less, like manhole inspections and what else was there? Maybe changing the bulb in a traffic signal, or aerial cable replacement, things like that. That's mobile. But then moving is when you're constantly moving, like street sweeping and pavement marking, striping and mowing, things like that. So ODOT crews get a lot of training when it comes to mowing along our 2-lane roads. And because all of our 2-lane roads are a little bit different. Remember, I talked about the variables when it comes to your roadway environment where you're working. And the presence of shoulders makes it nice for the mowers because they can stay on the shoulder while they mow. And, that means that's usually typical application number 4 because it's just a shoulder operation. But if you're in the lane of traffic while you mow, that makes you a mobile operation. That's moving. But, I say mobile because that means you have to set up according to TA 17 or TA 35. And so that means you need protection from like a shadow vehicle, and maybe even think about, signs beforehand to let the motorists know that there is mowing ahead. You want to be specific so the motorists know what to look out for. And so, we train our ODOT crews for our 2-lane state highways, because some of our state highways are nice and flat. You have nice sight distance, and that makes it, that's a good idea to use the mobile operations there. But once we get into areas where there's lots of curves and hills and dips, then that makes it dangerous for the mower if he's in the lane of traffic. And so, that's the way it is for county and township roads in rural areas. So sometimes we don't even use the mobile operations in those instances. We use a flagging operation to make it safer for the mower, so we can better protect the mower and better guide traffic around them, making it safer. We remove the element of a possible surprising the motorist from happening.
Thank you, Ray. We have a follow-up question to that.
Okay.
Um, they said they saw an ODOT mowing operation just the other day and was surprised to see that they had a whole long line of trucks with lights on them blocking off the area instead of just an advanced sign and a shadow vehicle.
Yeah.
It was probably at least a half a dozen of them. Can you explain
Mm.
why it was done that way?
Sure, because I mean, if you read the notes page on TA 17, it talks about options, and as I said in part number 1, when you're dealing with a roadway that has high speed or high volumes or sight distance restrictions, you need to adhere to not just the standards that's listed in the notes page, but also the guidance and options. And some of the options for mobile operations entail having additional shadow vehicles, even shadow vehicles in other directions. You could even put law enforcement vehicles in there as shadow trucks. So hopefully you also saw truck mounted attenuators in there. So um, you can't just look at the picture and that's all. Then of the typical application, and that's all there is. The notes page are there because there's so many variables when it comes to the roadways, and the notes page helps you to deal with um, situations that you don't see in the picture, and so what to do when you have higher volumes and higher speed. High speed starts at 45, so if you're working on a 2-lane road that's 55, you can't just have the bare minimum standards. You got to beef it up with what's listed in the guidance and options, and that's what that crew was doing. Okay, so I also wanted to show, well, let me see, I'm not done here. So this kind of helps answer that same question. So this slide says you need to take careful consideration of the location. That means location within the right of way, as far as being on a lane or in a shoulder or off the shoulder or in a median, the volume of traffic, speeds, and time of day. Maybe you shouldn't be working in a mobile operation during the morning or PM peak rush hours. And of course, visibility is a key factor. Um, that means visibility of all your temporary traffic control devices and the workers and your vehicles. That's why one of the standards is high intensity strobes. Advanced warning, you definitely need to make sure that the public knows that you're out there. So I can't stress enough the need for advanced warning. And then control. Think about, how will the motorist know how to get around you? And that's a definite consideration when you're selecting a mobile typical application. And so, like I said, ODOT crews, they don't combine flagging with mobile because we're always in high speed, high volume 2-lane roadways. That's why it's a state route. You know, once you hit a certain volume of traffic, that means, hey, that should be a state route, not a township road. That was decided a long time ago, obviously. So, you know, we only use the mobile operation when it's obvious that cars can come up behind us and then see around us and be able to make that decision to pass us. And if we start to build up a long line of traffic, then we pull our operation off on the shoulder and let people go around us if they can't get it, if they don't have the sight distance. Because we have that ability, because most of our state routes have a nice wide shoulder. But when you get to the county and township level, they don't. And so, you know, they have to figure out how they're getting traffic around them before they leave the garage and select the typical application that's for mobile operations versus flagging. And so one of the things I wanted to show was a typical application that's used in other states. So which one? It's for instance, Indiana. Can you see my screen, Kara?
I sure can.
So it says Indiana Local
Yep,
Technical Assistance Pro. Okay.
sure
All right.
does.
So here's an example of Indiana, their temporary traffic control manual. You know, like I said, the federal manual of uniform traffic control devices was just updated in December of 2023. You know, that's the first time it's been updated since 2009. And so now ODOT has like a year and a half for us to come up with a supplement to the new MUTCD. And so we have things to consider because a lot has changed since 2009. And so a lot of other states have other typical applications that we don't here in Ohio. So I'll give you an example. One of them involves the mobile operation on a 2-lane road. So here's TA 17. Let me zoom back out. So TA 17 in Indiana is identical to Ohio's. So there's TA 17, mobile operations on a 2-lane road. But their next typical application is something we don't have in Ohio. It says mobile operations on a 2-lane road using flaggers. And it's typical application 17AY. And so the point of all this is that if you are going to flag traffic around your mobile operation, then you need to do it like it shows here, and that is have signs out there to let the motorists know to be on the lookout for flaggers. You don't want to surprise motorists, especially at high speed, that there's all of a sudden a flagger telling them to stop, okay? That would be extremely dangerous for the flagger. So if you're going to be flagging traffic around your mobile operation, have the signs out there in place for the motorists to be on the lookout for flaggers. Okay, so it's most likely that what's going to happen is Ohio, we're going to decide about accepting this typical application to be in our new supplement to the new MUTCD. Like I said, we got about another year and a half to finalize that, but we're starting to work on it now. And some other changes will be roundabout lane closures for work zones. And so let's take a look at what Indiana has, because that's probably what we're going to have. So here it is, short duration work in a 1-lane roundabout. And so you see, since it's a 1-lane roundabout, they're going to use flaggers to close one quadrant of the roundabout at a time. So in this picture, you see they're closing the southwest quadrant of the roundabout. Let's zoom in a little bit. And they're setting up the signs in each direction, just like in typical application number 10 for flagging. and it shows you the cone placement and where the flaggers are standing. There's a flagger on each leg of the intersection. So that's when you have a single lane roundabout. But then if you have a multi-lane roundabout, it's a different ball game. So we don't use flaggers in where you have a 2 or 3 lane roundabout. There's the famous 3-lane roundabout there in Dublin at 161 and Riverside Drive. But this here shows a 2-lane roundabout, which is much more common. And so they're using the temporary traffic control devices, much like typical application number 33 for a lane closure on a multiple lane road. So they're using arrow panels, and they show the merging taper and the same signs that are used for typical application number 33. So these are sorts of things that'll be coming about with our new supplement. Okay. All right, so and then back to our mobile. Of course, I went over the standards for mobile operations, and one of the standards involves you must have, it says you shall have high intensity strobes and things like that on your work vehicle. It says shadow and work vehicles shall display high intensity rotating, flashing, oscillating, or strobe lights. So at ODOT we have a lighting package that we call a 360 view for our work vehicles that are permitted to be used as shadow vehicles. And so we've got our high intensity strobes up high on all 4 corners of the vehicle, and then a light bar on top of the vehicle. And so what you see in this picture is a work zone setup that goes along with typical application number 35, which is mobile operations on a multi-lane road. So you see their arrow panel is set to arrow mode, unlike the typical application number 17, where it would be set on caution mode if passing were permitted. Okay. So, the locals, they've got different types of streets to contend with as they make their decision on which typical application to use for the work zone setups. And so let's take a look at some of these local streets. So we have our low speed residential areas, like your residential streets. You're in a subdivision, speed limit 25, you got low traffic volumes, low speed 25 miles an hour. You don't have to install all the signs you see in a typical application. So I mean, usually your high intensity strobes will work, maybe one sign, things like that, and a few cones. Okay, it's not a big elaborate setup. And then we get into our suburban streets. And so, especially our suburban arterials, like in the picture you see there. So typically more hills and curves. And so we will need to have all the advanced warning signs, even for short duration projects. And then what if you're on a high speed roadway? High speed, that kicks in the need for, as I said, the guidance and options that are listed in the notes page. So they're showing the arrow panel attached to a shadow vehicle. This is a high-speed multi-lane roadway in that picture. And there's other typical applications involving mobile operations like shoulder work. And so that's typical application number 4 you see on the right. They're completely off the shoulder, completely on the shoulder, not in the lane of traffic whatsoever in number 4. But then we also have number 6, TA-6, is when you are sticking out into the lane of traffic. And so at ODOT, when you read that TA6, you'll see that it shows in the picture that we're only permitted to narrow that lane down to 10 feet wide. And that makes sense to ODOT workers because all of our lanes are 12 feet, so we can encroach on that lane by a maximum of 2 feet. But if you work for a local government, like City of Columbus, then it's a whole different ball game because a lot of your streets are not 12 feet wide. You might have some 11 feet wide or 10 feet wide or even 9 foot wide. And so you have to come up with your policies for each type of street you're working on as to how narrow you can make that lane. How far are you encroaching into that lane before you have to make the decision to close the lane entirely. So that's why TA6 exists. It shows you an example of the travel lane encroachment, but it also gives you guidance on just how narrow you can make that lane. And so it depends on what type of street you're working on at the City of Columbus. Is it a residential street with no commercial traffic or not? And so, you can come down to 8 feet on some of these residential streets. And then maybe you cannot encroach at all on some of your arterial streets if they're just depends on how narrow they are. Maybe you have to do a full lane closure because you don't want to create the situation where you have cars sideswiping each other or hitting each other head on because you made the lanes too narrow. Okay. All right, we talked about that one. Here's the TA35 mobile operations on a multi-lane road. When ODOT workers look at this picture, it makes perfect sense because, it's showing a 6-lane freeway and with big wide shoulders. And so there's obviously lots of room on our freeways for a shadow truck to be totally on the shoulder, and then a second shadow vehicle to be in the travel lane protecting the work vehicle. Makes perfect sense. But if you work for a local government, you're probably thinking, what in the world? What am I looking at here? We don't have that situation. So, if you have a curb and gutter street with no shoulder, then you would just eliminate the need for that shadow vehicle number 2 on the shoulder. So that's how you would deal with that. But the notes page that goes along with it walks you through some of that process as well. Here's a mobile operation that's set up for mowing. It's typical application number 1, and it's for when you're mowing beyond the shoulder of the road. So as you can see where the work area is in that picture, so when ODOT crews look at this, they're like, oh yeah, that's the 2-lane state route I mow on. Nice wide shoulder, but I have to mow off the shoulder as well. And for the clear zone that we call it, and to enhance sight distance off the side of the road, add safety to the roadway. But so we're not even on the shoulder, we're beyond the shoulder. So just a road work ahead sign, maybe mowing ahead is what is all you'll see in that. But that's great for ODOT workers, but if you work for a local government, you probably never have this situation because you go from your travel lane to a very narrow shoulder and then into a ditch. So you probably don't have this situation. All right, so but when you select the typical application for mobile operations, it says, use common sense. How much advance warning do I need? And then, literally put yourself into the driver's seat of the motoring public and ask yourself, what will the experience be for a motorist to be coming up behind me at the speed limit? And will I surprise them? Will they know we're out here in advance? Because that's That's the most important aspect of your mobile operation is advance warning and the ability for the motorist to know you're there from a safe distance. So, how much time and distance do the drivers need to adjust their speed? And so you have to be careful about selecting the mobile operation. It takes some good planning and discussions with your supervisor or even the supervisor. So very important. So that's all I have for the mobile operations. Um, so let's move on to street closures.
Hey Ray, real quick, we have
Yeah.
one more question from
All right.
let's see here. It says there was a conversation in a DSRT meeting about the danger of sitting in a disabled vehicle on the side of the road. Um, do people sit in shadow vehicles or do they just sit there empty since they're designed to be a buffer?
Yeah, they're following along with the mobile operation. So if the operation is moving, the shadow truck is moving, but if they're stopped, and they are stopped. And so the typical applications notes page, it talks about the job of the shadow vehicle as far as visibility. So it says, let me get there. When you when you read the guidance portion, it says the shadow vehicle should slow down in advance of vertical or horizontal curves that restrict sight distance. So it's telling you that the shadow vehicle should never disappear over a hill or around a curve, uh, because that would definitely surprise the motorist, and uh, that could be a crash. Um, so yeah, if the crew is in the lane, then you need to be in the lane. I mean, it's very clear. And if you're choosing typical application number 17, then the setup is drawn for you right in the illustration. Um, if you're on the shoulder, then it's the picture shows the operation. Typical application number 4. Um, I hope that answers the question. If you have a fear of being struck, then maybe you should not be selecting that typical application. You should choose flagging instead, because the flagging definitely provides more advanced warning and guidance around the operation. And like I tried to allude to, is that you don't just automatically pick the mobile operation. You got to think about that. And on a 2-lane road, you got to decide between mobile operation and flagging. And that's just some of the stuff that you think about. Like I said, the variables of your roadway. One of the variables is sight distance, things like that. Okay, so moving on, street closures. So sometimes we just want to say, you know what, the safest work zone here would be just to close this street down. And in a lot of our roadway maintenance operations, we do close streets. And there are several typical applications dealing with street and road closures, and also walking you through the process of setting up a detour. And so, but when we do close a street, you got to realize public relies on uh, traffic control. They need to understand how to get where they're going since that street is closed, and you don't want to leave drivers confused or too inconvenienced, and it may require a detour. Um, so traffic control is very important, even at low speeds. The drivers and other users need to know their options. Uh, let's look at different street closures. Sometimes we have closures without any notice to the public. We just need to close the street. So this is common during emergency situations. And in that situation, law enforcement has the authority. Sometimes law enforcement calls upon the local street department to help them with the street closures. Then we have planned road closures. The street department, they don't need permits to close a street down. their agency owns the street. But if you're a contractor doing a job, you obviously need to consult with the proper authorities and get your permit to close the street, and of course the work in the right-of-way permit that is based upon an approved construction plan, a signed construction plan by the engineer who owns the roadway, and all the other pertinent divisions of that agency. So basically there's 4 types of street closures: emergency, short-term, long-term, and special events. So as volumes and street size increase, so does the planning and traffic control required. So, in your slides, we go over all the different types of road closures from emergency. Emergency is you've got no time to preview the site. Might be a road flooded or some law enforcement situation. You may have to improvise with whatever available devices you have on your work truck. And then to set up, you might have to close with a work truck with all the strobes and arrow board on temporarily until you call for more equipment and have the proper temporary traffic control devices. Make sure that they are delivered to the scene as soon as possible. Then we have our short-term road closure. So this is more like the typical road closure. It's a planned event, usually for roadway maintenance, 12 hours or less during the daytime. Workers are present, and then they follow along with some approved maintenance plan or construction plan. So we want to make sure that you set up the road closure to follow one of the several typical applications for road closures. And so you'll have the barricades and signs, maybe even some warning lights on the signs. And so there's different levels of what's required depending on the type of street. So the lowest type of street would be a residential street with low volume, low speeds. Sometimes you can close those type of street down with just cones. You don't need the big barricades. Maybe you don't even need a detour. However, if you do have poor visibility or obstructions, that maybe you do need additional advanced warning signs. So you got to use judgment. So what else do we have here? Setting up a detour. So if you're the street crew, obviously this is a planned event. You have a plan to follow, and there's a lot of planning that goes into a detour, especially in a city. So you need to check, make sure you do have your plan is signed off on with all the pertinent people and agencies. You want to even notify emergency services, law enforcement, and then clearly mark the new route with signs. And let's take a look at the different typical applications regarding detours. So typical application number 19 is titled Detour for One Travel Direction. And so when you look at this street, the north-south street on the right side of the picture, it's a 2-lane street, but the southbound lane is the only one that's closed, and it's closed for a few blocks. And so the northbound lane is unaffected. It's still open. And so you have, you can see how the signs are placed to get the southbound traffic over to the next street, parallel street, and to go around. So a lot of cities and villages have that situation. I know when I was at the city, the utility department they were relining water lines or sewer lines or something on High Street, but they would close they were just like in that picture, they were closing a southbound lane for about a mile. And so, but the northbound lane stayed open. So that's basically that's the typical application that was used. And then typical application number 20, you see a street is completely closed. Both lanes are closed. And so the traffic, both directions of traffic have to go over to the next parallel street. And so shows you the example of the placement of the road closed ahead signs and the barricades and the detour arrow signs. And of course, if you work in a city, sometimes the street stays open, but you've got other work to do, which forces you to close a sidewalk. And so if you close a sidewalk, then you need to adhere to typical application number 28, where it helps you to create a sidewalk detour or a sidewalk diversion. So the pedestrians can still stay relatively close to the sidewalk, but they're going to go around it, as you can see in the picture on the right. But if it's completely closed, then you have other signs down at the intersections on the north and south sides of the sidewalk closure, telling them to close the street, cross the street there. So then I've got several slides here that go into detail of how to install and remove all the signs you saw on those detours. And so it's actually, you install and remove these signs in the opposite way that you're used to doing for lane closures. So we actually install against the flow of traffic and remove with the flow of traffic. And so, like, you see all these signs here. So it's like, so how would you install and remove this? So, you got to locate and plan out where you're going to install these detour signs. And so you would begin the installation with the last sign in the detour series before establishing activity signing and placing devices. And so you've got to have, when you have all those signs, it makes sense that you would actually inspect those signs quite frequently to make sure they're still in place. And you would navigate from the public's point of view, and you check the signs for visibility, warning, and control. And so long-term closures, that's another type of street closure. So we see these all the time, especially this time of year, because we've got major utility repairs or even road construction projects are beginning. So these long-term closures, they might stay in place for days, weeks, or months. And so when we have these long-term closures, we got to upgrade our temporary traffic control with our type 3 barricades. We might even use different types of barriers and fences. And of course, communication and proper placement is essential. And so there would definitely be an approved maintenance of traffic plan showing just how this long-term closure would be set up, and making sure that all devices have excellent visibility, and there will be scheduled inspections that are well documented. And so you might see signs like this: road closed to through traffic. And so here's some other requirements. Sidewalks that are pay attention to hazards, such as sidewalks that are out, material equipment storage, excavations, piles of debris, and manholes. That looks like kind of a mess over here in that picture, doesn't it? Okay, so I've got there's some upgrades there as far as place flashing warning lights on type 3 barricades. So as you're inspecting your temporary traffic control and make sure that's adhering to the approved plan, you're going to drive through the detour and look at it from the public's point of view, and just make sure it makes sense to you. If not, you need to make some adjustments. Make sure you discuss those adjustments with all the people that approve that plan and document those changes. Special events sometimes require road and street closures and detours. I mean, every small city or village in Ohio, usually, or even the big cities, have special events like parades and marathons and things like that. And so it says police help control traffic, but you still need traffic control devices. And so there needs to be an approved plan. I mean, if you think of the red, white, and boom in downtown Columbus, you know, that committee, they meet year round on exactly how to set up all the necessary street closures and all the temporary traffic control devices that are needed and where they need to go and all that stuff. So a lot of planning with people from all the affected divisions and agencies. And so you have different types of streets. I mean, if you think of downtown Columbus, you've got your main arterials where you're going to have type 3 barricades, but you might have alleyways and side streets that maybe something less than type 3 barricades might be used. Okay, so in summary, you've got your 3 fundamentals of our temporary traffic control: visibility of all of our devices. Make sure you focus on providing the advance warning, and then make sure that traffic is controlled all the way through. You know, the guidance that I talk about, advance warning plus guidance, good planning, have with trained workers, proper devices and procedures. You know, that just means, you know, follow the manual as much as you possibly can and use your common sense and judgment. So before I get to questions, let's get into some you know, what other resources do we have to help us set up our work zones? One is Google Maps. So let's take a look how Google Maps is a nice and free work zone design tool. So you know, I can combine that with some quiz questions. So like if I wanted to close a lane on let's talk about my favorite state route that I drive every day, like Route 23. You know, they have a saying in Southern Ohio: reading, writing, and Route 23. Made famous by Vern Rife. Okay, so anyway, let's say I'm my jet copter here. So there's Route 23 there in the picture. Let's say I need to close a northbound right lane. So the first quiz question is, so I take a good look at, I can even use Street View. I have the aerial view plus I have Street View with Google Maps. So if I want to close this northbound right lane, class, why don't you tell me which typical application I would need to use as the basis for my work zone design? You know, it's kind of like step 1 in our work zone design is take a look at our work environment and what we need to do, and then select a typical application. So you tell me in the chat box which typical application we would want to use for a right lane closure on a multi-lane divided highway.
Ray, this is Victoria.
Ray,
You're getting radio silence.
I am.
Oh,
No
no.
one's.
we have one person that says TA33.
Oh,
Yeah.
so we've
TA33.
got one response. Okay, with
No, we're up to 2.
well, typical application 33 is correct. All right, so then the next step in our work zone design is to use those tables that we talked about last time. As tables on page 17 of the guidelines for traffic control and work zones. Maybe you downloaded that, or you have the app downloaded to your phone. So if you look at those tables, is that one of the handouts, or is it are they on their own here? So if I let me remind people how to find that resource. So if you're on at the Ohio LTAP webpage, can you see that, Kara?
Yep, I can see it
All
great.
right. So if we're on the Ohio LTAP webpage, we scroll down. If I want to find that manual, I click on Technical Assistance, Services, and Resources right there on the right side of the screen. And then that page downloads, and then here I see it. I'm on the Technical Assistance, Services, and Resources page. And so the third row in our resources, let's look at the third and fourth rows. Those are very important for this class. So in this third row, we see guidelines for traffic control and work zones pocket guide. So it's right there. And then in the fourth row, we see a direct link to the Ohio Manual of Uniform Traffic Control Devices. And so if we click on guidelines for traffic control and work zones, then here we are on that page. And then I can scroll down and I click on the download button. And so here it is. So if I zoom in on it, I want to scroll down to page 17. So I just want to make sure everybody's looking at these tables. Okay, so here's page 17 on your right. Okay, so now we're at the stage of the game where we're using these tables in conjunction with typical application 33. And so the first thing I need to figure out is how to space our signs. In the typical application 33, it shows us a series of signs, and we place them on both sides of our, since it's a divided highway, we can put the signs on both sides of the road. And so we have to figure out what kind of road is Route 23. And so I showed you a very rural location, but is 23 an expressway or freeway? It's not. And so it's rural. So our sign spacing would be 500 feet. So then we can look at, and then as we're looking at TA33, let me bring that up because I don't know if everybody sees it or not. So let's go back to our technical assistance page. And I want to click on the Ohio Manual of Uniform Traffic Control Devices page, link. And then I scroll down. Here's all the different parts to the manual. But here's part 6, Temporary Traffic Control Manual. So we'll click on it, and it quickly downloads. And now I want to go down to TA33. The multi-lane roadway typical applications begin at number 30. And so here's TA33. Let's zoom in a bit. So there's the notes page, and then here's the illustration. Let's zoom in a bit. So trying to move this box out of my way. Okay. All right, so at the bottom part of the picture on the right side of the screen here, let's zoom in a little bit more. We can see exactly what signs to use. We got the road work ahead sign. That's the first sign, and you can see in the picture how it's placed on both sides of the road because it's a divided roadway. And then the second sign is right lane closed ahead, and then the third sign is the symbol of the right lane merging over into the left lane. And then we go a distance of A, and then we place our arrow panel on the shoulder, and then that's exactly where the merging taper begins on the white edge line. You see a shoulder taper in front of the arrow board. The shoulder taper protects the arrow board. And then when you get to the white edge line beside the arrow board, that's where the merging taper begins. At length L, you see the length L. Then when it hits the center line, then we go a distance here for the buffer space. So the buffer space is a completely vacant area. And then at the end of the buffer space, we can place our optional truck mounted attenuator that's mentioned in the also in the notes page. And then there's our work area. So let's use this picture. And so the quiz question is, with a speed limit of 60 miles per hour, what is the distance from the first sign, the road work ahead sign, to the workspace? So now you got to add up all these elements. You got C plus B plus A plus L, that's the length of the merging taper, plus the length of the buffer space. So if you add up all those for a 60 mile per hour design speed, what distance do you come up with? Okay, class, see who gets it right first.
We have a 2020, 2220. We have a 2070, 2790. We have 2220, so that would be our second 2220. We have a second 2790, 2415, 2220, 2095, 2280, 1200, 2340, 2220. All right, that might be
Wow.
about it. Oh, we've got a 2795.
I wonder where they're getting the 5 at.
I don't know. Let's see here. Oh, someone wanted to change theirs to 2290. We have 2420.
All right, let me
2790.
reiterate now. We got the 3 signs with a spacing of A plus B plus C. Then we have our length of the merging taper, and then we have the length of our buffer space. Make sure you add all those together. All right, 10 more seconds. And then we'll reveal the answer.
Someone says 2790, 2790, 2790.
All right, we'll stop on that because that's correct. 2,790. So if I look at this picture on the right, and I'm using these tables here, So A plus B plus C, I'm looking at the top table here on the right. So 500 plus 500 plus 500, that's 1500. And then the next element in the typical application is the length of the merging taper. So I go down to the bottom of the screen. I remember I said 60 mile per hour design speed. So I look at 60 miles per hour. And then the third column shows merging taper. And I see a value of 720 feet right there. So I got to add that to it. And then the final element is the far right column on the bottom. At the top, it says buffer, flagger station and buffer space. So I go where 60 miles per hour, go all the way to the far right under buffer, and it says 570. So 500 times 3 plus 720 plus 570, that equals 2,790 feet. So everybody that came up with that number, you win the grand prize. Good job. Okay, so then I can use Google Maps. Okay, we're not done. So that's the first two parts of the work zone design process. And so now I want to use Google Maps. Let's say if I have a big giant pothole up here where it says Circleville Township Trustees, even with that, but it's in the northbound right lane. If I want to find the distance of 2,790 from that spot, that's where a big pothole is that we have to fix, by the way. Now I put my arrow at that location, and then I right click. And when I right click, this box pops up, and you can see measure distance at the bottom of this box. See measure distance? So then when I click on measure distance, then the next spot that I click on is going to give me a distance. So if I come down here to the bottom of the screen with my arrow just to guess, then if you can read the bottom of my screen, it says 3,498 feet. So I know that I guessed too far, so I'm going to clear the measurement, and then I'm going to click measure distance again and guess something closer than that. So like in this area, let's say there, then that total distance is 2,300. So if I let me guess one more time. Measure distance. Let's put it here. Oops, not even that. So I need 400 more feet. What's that one here? So what did I say? 27. So I can keep clicking further away. So there's 2,700 and something. So whoops. Clear measurement. So now I can what I want you to do then is, let's do that again. All right, so what you would do here, I have it all measured out. You can print this screen out. Of course, it wouldn't let me get the whole thing there. You could print screen as it is. So it's going to print with these measurements in place, and it has the 100-foot tick marks, okay? And so when you print it out, then you can work with it. So if I zoom down here and then hit Street View, then I can see where my first sign is going to be. So you can see on Route 23, you got a nice shoulder over here. So I put a road work ahead sign there. And then over here on this side of the road, I put another road work ahead sign. And then I would go 500 feet. And, you know, I would check on that, the picture I just printed out to go down to the 500-foot tick mark. And then I would know that my right lane closed ahead signs would go at this location. And then, you know, I could write all that on that picture, and then have the next sign and show the arrow board placement where it goes, and then the length of the taper of 720 feet, and then the length of the buffer space. I could mark that sheet up and show exactly how it's going to be laid out to the crew. I could even make copies of it. And then I could also do some more calculations with this chart. The question for the class is, what is the minimum number of cones I need in my merging taper? Okay, so the merging taper is 720 feet long. I can use we're going to use this middle table, maximum spacing of channelized devices. I have a 720 foot merging taper, and it says here in the second column, on a multi-lane road, the spacing is the speed limit in feet. So the speed limit's 60. Okay, so what I would recommend is don't design the spacing for 60. Once you dial it back, let's do 720 feet length with 50 mile per hour. That's dialing it back, because in a work zone, traffic is going to slow down. So if you or even 45. So let's go 45 as the design speed for the spacing. So what would be the minimum number of cones you need just for the merging taper?
We have 45, 16 cones at 45
Okay.
foot spaces, 16 devices.
All right. Well, that was kind of a trick question. I mean, I wanted you to say 16, but you actually add one because your first cone would be at 0.0 on the white edge line. So anyway, 16, 17, but the main reason I talk about the minimum number of cones in a taper is because the motorists, they need to see that taper from a distance. And so if your work zone is set up properly, you're going to see that motorists, as they approach, are going to see the signs and the arrow board and the cone taper. And that cone taper is really going to stand out if you actually calculate, how many cones you need there for the speed that you project traffic to be going through there. The objective here is so that when traffic is going by your cones, that they're whizzing by them, they're flying by so fast that they know they're not supposed to drive between them, or they couldn't drive between them if they wanted to. That's the way you want them to feel, because you definitely don't want traffic to drive between the cones, right? And so when you're working on a merging taper, you're using that type of taper for a very busy road. It's a multi-lane road, and at high speed especially. And so, but if you design it for the speed limit, then what you're saying is that traffic is not slowing down for the lane closure. And but if they do slow down and they're spaced, if they're slowing down to 35 and 40 miles per hour, but you have the spacing for 60 miles per hour, then you run the risk of them thinking that it's okay to drive between the cones. And so you don't want that. So you want to think about what is the actual speed going to be for traffic, and you want to design you want the design speed for spacing to be, maybe even for slower than they're actually going. you're allowed to put your cones side by side if you want, but you probably don't have that many cones. But you know, when you got to put some thought into the spacing. And then you can see in that table that the spacing of cones is different between the taper and the buffer and workspace. And so when you get past the taper and into the buffer and workspace, then you're permitted to have the cones further apart. It says 2 times the speed limit. But there again, you want to think about, you know, what is the actual speed of traffic, not just the speed limit, but what do you think the actual speed will be? If you're thinking that you're going to be slowing traffic down, then you need to have them, you know, think of the speed limit being lower than the actual speed limit. Okay, so that's a good example of a rural work zone setup on a multi-lane road. And so, well, let's take a look at an urban situation. So if I go back to my jet copter, first of all, was there any questions on how we did that? So, you know, in my work zone design steps, procedure, I guess you would say, you know, let's reiterate that. We want to select a typical application that fits our work environment. And then we use those tables to help us as far as sign spacing and length of tapers and buffer space and things like that. And then we can use Google Maps to get a good aerial view and street view. Street view is really helpful because it shows where you can actually place your signs. You know, is there a good shoulder for sign placement, or is it maybe it's kind of confusing where to put the signs? Maybe you got to do some work out there to figure out where to place your signs. Like maybe you got to do some vegetation management along your county road. Yeah, depending on the time of year, you know, in August, that's when the vegetation's going crazy. Maybe you got to take care of some vegetation before you put your signs out there to make sure that they're visible from a distance. Okay, so let's zoom in on City of Columbus and look at another multi-lane road to see if we're going to use the same typical application or not. And
Ray, we have a quick question for you from a
okay,
participant. They want to know if you ever factor in additional safeguards for agricultural considerations like harvest time, planting time, things like that.
I was just having that discussion yesterday. Let's see, where was I? Was in Norwalk. Here's hello to all my friends in Huron County that I was with yesterday. But I know I was driving up through there and I saw lots of farmland and farm equipment. I saw a lot of farm equipment on the road yesterday. So I appreciate that question. But I know a lot of county engineers and township trustees, they do factor those in. So yeah, the answer is yes. And so how do they do that? Well, yeah, of course, roadway maintenance activities are probably using portable signs. So they can adjust those as needed. But then, you know, long term, that's even more important because you got post-mounted signs. We definitely don't need the big farm equipment to knock down those signs, right? Hopefully the farmers aren't making a sport of knocking down our signs, like, and I think some farmers do that, but you know, at least hopefully the farmers would make a phone call to the agency and let them know their signs got knocked down. But Sometimes you have to be, I think I was at the Huron County Engineer's office yesterday when a farmer actually called into the engineer's office and talked about some stuff. So I guess if you live in those farming communities, it makes good sense to have a good relationship with the farmers. Okay, so let's take a look at a Columbus arterial, multi-lane arterial street. And so street view is, as you can see, very helpful here. But here we are on 4th Street at, let me see, what is this side street? 4th and Main. Let's say we're at 4th and Main, and our big pothole opens up right here in this northbound right lane, right in front of this. Looks like a driveway to this parking lot. Let's see what that looks like. So it'll be in this location here. I don't think that's a driveway. Yeah, that's curbing there. All right, so we don't have to worry about a driveway. But right here in the northbound right lane, right by the bumper of this SUV, a big 4 foot by 4 foot pothole opened up overnight. Yikes. So it's going to take us about 4 hours to fix, because it might be some utility work in there too. So what typical application am I going to use on this multi-lane city street? So let's get this. Here's the aerial view. So we're only about, the pothole is a distance of about 120 feet north of Main Street. So
We
it's not
have
some
TA35,
TA35.
222,
Okay.
19,
19. Oh, let's look at 19. Oh, we're just going to close the. Well, I don't know.
I think that's about it so far.
Okay. All right, well, let's go over those answers. And TA19, that's for like a 2-lane road where we're closing one direction, like a southbound direction. So I don't think that would be it. Then I heard TA35. The problem I have at TA35 is that this is not a mobile operation. It's going to take us, like I think I said, 3.5 hours. We're going to be in a stationary position. So it's not a mobile operation. And then I heard TA22, and I say bingo to that one. So let's look at TA22. And so it's very different than TA33. So let me zoom out and scroll back up to TA22. All right, so here's a picture of TA22. Let me zoom out to get the whole thing here. So it's titled right-hand lane closure on the far side of an intersection. And you might look at this picture and say, well, Ray, that doesn't look like our location. Looks like 4th Street's got 3 northbound lanes and on-street parking, and really doesn't look like it, Ray. What do you mean, TA22? Well, you know, this picture is drawn by ODOT, so we have to translate that to an actual city street. And so, you know, we have to be able to deal with these differences of on-street parking and more lanes than what's necessary. But the main objective here is that we're closing a right lane on a multi-lane road. And it's relatively close to the intersection. And so, You know, it's very different from TA33 in that we don't need a long merging taper, and the buffer space, we're utilizing the safety of the intersection and how it controls traffic to our advantage. Okay, so as we look at this picture, we see some signs: road work ahead, lane ends, merge left. And then we see a regulatory sign used twice. It's not the orange diamond shaped sign. It's our regulatory sign. It's rectangular with a white background and black letters. It says right lane must turn right. And as we continue north, now we see an arrow board that's looks like it's used in conjunction with a barricade. And if we look real close, we can see the cone placement. And so we zoom in, we see the cone placement here, creating a new radius for right turning traffic to make sure they have a proper radius to get around the barricade and arrow board and into this lane. The good news is we can create an even bigger radius because we can move this arrow board a little bit north because we're not right up against the intersection like typical intersection maintenance work. So, and then we see road work ahead signs for the other directions.
Ray,
Yeah.
we do have one more question, and I just
Okay.
wanted to let everyone know we have about 4 minutes left.
Okay.
The question is, are there additional recommendations to address during inclement weather, assuming that the work can't wait until the weather improves?
Oh, by definition, you just talked about an emergency situation. So usually for the emergency situations, you know, you're going to have your more high intensity strobes, and maybe instead of a permanent sort of arrow board there, you might have an arrow board on a work truck and stuff like that. Maybe you won't have time to place all these other signs, but you can call in to have those signs brought to you. Because I was working for the city when they had a massive water line break on Main Street, relatively close to this location. It was like 12 degrees below zero. It was so cold that the fountain that was spraying out of the water main break froze. It was quite a nightmare. So I know what you're talking about. But yeah, you could, when it's an emergency, you gotta, you know, that's when your high intensity strobes and arrow boards, stuff like that, throw some cones out the best you can and call in for the proper temporary traffic control to be delivered by others. Okay, so do I have some other knowledge check questions, Kara? Let me see. I think I do.
Here, we do have a question from
Wait,
a
I've got some.
participant.
Okay, go ahead.
Why would you not close the right turn for traffic coming from the right?
All right, let's look at that. If it's in the illustration here, the eastbound traffic can still wait. Say the question again. It's for a right turn or a left turn?
Why for a right turn? So why would you not close the right turn for traffic coming from the right?
Okay, so if I'm on the east leg of the intersection and I want to turn right, I still have a lane to turn into. The side street in this case is a 2-lane road, 1 lane in each direction. They can still turn right. This lane is open. I hope that answered the question. I saw some other questions here, but I think I had the answers. Some of the stuff down here. These have the answers marked.
How about don't scroll down to one and give us that one? Oh, giving us the
What?
answers.
Yeah, they can see the answer. Anyway, um, if there's, well, we're about out of time anyway. So I just want to close by, let's see, did I have some other stuff here? No. So, we talked about so much information over this 4-part webinar series. Part one, a lot of general information about work zones, and we learned about the temporary traffic control manual and online resources from the from ODOT's Office of Roadway Engineering's page that has a cornucopia of work zone resources of all kinds, direct links to the OMUTCD and temporary traffic control manual, traffic engineering manual, all sorts of stuff. The LTAP website has resources as well. And we got into your different temporary traffic control devices and how each typical application shows us what to use, but we also went over the latest specs of each type of device and different safety devices, even about truck-mounted attenuators and aero panels, and how there's a grant for locals to purchase those through a grant through the Ohio Bureau of Workers' Comp. And then we got into mobile operations and flagging, and I even showed you some new typical applications that might be coming down the pike because we're updating the manual, like the combination of mobile and flagging and roundabout lane closures. And we got into street closures. And then I like to talk about Google Maps, how Google Maps is a free design tool that you can use the measuring distance tool on there to help lay out your work zone quickly before you leave the garage. It's important to have a plan in place before you leave the garage. And that way you can make sure that you load up your work trucks with all the temporary traffic control devices you need for a particular typical application. And what else? Kind of went through like a step-by-step process of developing a work zone plan. So I hope this 4-part webinar series was helpful to everybody in attendance. I know not everybody can attend an in-classroom training, so that's why Ohio LTAP wanted to provide this webinar series to all of you. And so I appreciate everybody taking their time and participating in this. And also make sure I get your sign-in sheets for everybody that's listening from a group, and that way I can get all of your certificates out to everybody. So it's been my pleasure to talk about all this stuff with you guys, and thank you again for participating. Anything else, Kara, for the good of the order?
We did have one last question and one comment. The question was, what would be the recommended distance from the intersection the work is being performed where you would not install the right lane must turn right sign?
Okay, let's look at this picture. So the recommended distance, it shows these distances on here. So this A, and B here, and then you see the right lane must turn right. They're using 2 of them. So distance A on a city street, that's low speed. So A is 100 feet. So they're showing, that means these 2 signs could be 50 feet apart because they're showing, as you can see, the 100 feet goes from the intersection to the lane ends merge left sign, and then another 100 feet to road work ahead. But when you're laying out your signs on a city street, you try to take advantage of the closely spaced intersections because where traffic's probably going to be stopping or slowing down at intersections. But when we look at what 200 feet looks like. 200 feet would be on this section, and the total distance from this intersection to the Noble Street intersection. Let me get that right here. Measure distance. So it's only 220 feet from one intersection to the other. 210 kind of went over there, but so basically your first sign would be, the road work ahead sign would be right here in this parking lane. So I know you would have to remove parking and put your signs on the proper sign stands in that parking lane. And you'd remove parking through here as well. Hopefully that answers your question.
And we have, let's see here. We have, thank you, very informational. We have that it's been an excellent course. Thank you for providing it. And one last question. Oh, no, we have a comment. You can drag a white dot on the Google Maps measurement to get quick length and direction changes. So.
All right. All sorts of resources there. All right.
Okay,
well,
everyone. Well,
be safe, everybody, and thank you for attending.
Have a wonderful rest of your day.
Okay.
Bye.
Bye-bye.